Hi everyone, in this video I'd like to talk a little bit about functions and inverse functions. So first of all, let's take a look at what a function is. So a function is really a map, and it needs to be a well-defined map. I'll tell you about that in a minute. So it's a map from the domain to the codomain that's well defined. Or another way of saying that is it sends every element of the domain to one element of the codomain. So it's a map from the domain to the codomain, which sends each element of the domain to some element in the codomain. Now, let's take a look at what that really means. So over here, set A, this is our domain. This is our starting set, and I think about a domain, I think about, you're the king or queen of your domain. That's where you start your day. You start in your house and out in the world you go. So your domain is like your starting set or your input set. So when I give you a function from A to B, the first little set there before the arrow, that's your domain. So set A here is our domain or our starting set. And then the codomain is over here in set B, and that's the set of possible outputs. So this is possible outputs, and we might not get all of those outputs. That's why I'm going to label it possible outputs. So if I want to define a map or rule that sends each of the elements of the domain to somebody in the codomain, I could go like this. I could send A to 1. And then I could send B to 4. And I can't stop there. Notice that so far, this is not a function because C didn't go anywhere. I need to assign every element, each element of the domain needs to get mapped to somebody in the codomain. And right now, what I've got is not a function because C got left out. C doesn't know where to go. So let's make it a function. So I have to send C somewhere. I don't care. I'll send it over here to 2. Now, I cannot get carried away. I cannot send C to 3 also. I couldn't send C to more than one spot. You have to take each element in the domain and send it somewhere in only one place. You can't send somebody to 2 places. It's like, going to the Department of Motor Vehicles and they tell you to get in line 1 and get in line 2. That doesn't work. So, actually, I love the Department of Motor Vehicles. I don't want to say anything bad about them, but sometimes we go there and we get confused. So the point is, we're going to take an element from the domain, every element from the domain, and we're going to send it somewhere. And when we do that, we get a function. We get a function from A to B. So I'm going to label a few things here to make everything clear. Our domain is set A. So the domain of the function that I have is the set ABC. The codomain is the set of possible outputs, and it's the set that comes after this arrow in, F goes from A to B. So in our case, it's the set 1, 2, 3, and the range is your set of actual outputs. So the elements that I actually hit over here in my target space, it's just the 1, the 2, and the 4. 3 was a possibility, but I never hit it. So my range is just 1, 2, and 4. All right. That was fun, but let's take a look at something more exciting, which is called the inverse function. So I'm going to make a little space here for us and talk a little bit about inverse functions. So inverse functions basically go backwards. They undo what the function did. So let me give you an example and then I'll define it. Suppose we had a function. I'm going to send 1 to 4, and I'm going to send 2 to 5, and I'm going to send 3 to 6. This is not a very exciting function, but it will work for our purposes. So in this case, our domain over here is the set 1, 2, 3. In this case, our codomain is equal to our range, and that's the set 4, 5, 6. So we had a function that went from 1, 2, 3 to 4, 5, 6. And we couldn't tell how that function worked looking at the picture, the arrow diagram. I could also give you a little formula. I could say, well, here's your input set 1, 2, 3, and the algebra you could perform to do the function would just be x plus 3. So if I give you an x, the output would just be that value plus 3. So the inverse function goes the opposite way. So if I wanted the inverse or the pre-image of 4, I need to go from 4 back to 1, or 5 back to 2, or 6 back to 3. And the notation for that looks like F inverse. So here F inverse is a map from 4, 5, 6 to the set 1, 2, 3. And the rule is, you can see the rule in the picture. 4 goes to 1, 5 goes to 2, etc. But you could establish the rule here by saying f of y or f of x or f of, smiley face. I don't care what you call the variable. I'm just going to tell you what to do to the variable. And what you have to do to your input variable here is subtract 3. That's how you undo the f function, right? If f meant add 3, the inverse is going to be subtract 3. And we see lots of other inverse functions when we're out there working in math, with square function, square root, the exponential function, and the logarithm. So there's lots of things that we can do and undo, and that's really this idea of an inverse function. I'd like to define that more formally for you. So as a definition, let f be a function from a to b, and this is going to be a one-to-one and onto function. Then f inverse is a map from b to a, and this is an inverse function of f if and only if, and here's the real punchline. If and only if f composed with f inverse gives you the identity map. So sometimes you'll see that as a 1, sometimes you'll see that as an I, and f inverse of composed with f is the identity map. So for example, if you had f of x equals e to the x, and f inverse, I tell you, oh yes, I think that's the natural log of x. Well, you could verify this by doing function composition. So f composed with f inverse would give you f of natural log of x. And f of natural log of x would be e to the ln of x, which is just x. In other words, it gives you back the identity function. It's the identity function because you inputted in x and you got out in x. The x was unchanged. So it's the identity map. And you can verify that F inverse composed with F also gives you the identity in this case. So what this means is that your function and the inverse essentially undo each other. And if you need to do a proof with the function and its inverse, be sure to use the definition, and that will give you some tools that you can actually compute and work with and derive results with. But this is the piece that you would need if you're working with a proof.